But yeah, next up we have Wim Henderickx, who's going to talk to us about cloud is in the air.
Hello. Yeah, so actually this is my first talk as our experts in America, so I'll try to give a bit of a different perspective on network, because at the end of the day we are all in the networking space, but what I try to do in this session is look a little bit from the cloud side of things, what is happening over there, and try to see how that applies to the networking and so on and so forth. So before I go into more details, I would like to see who of you in this audience is actually involved or is busy with clouds, and that's through hyperscalers or private. So is it possible to see, show hands, who is actually involved some way in cloud type of activities? So very few people, so this will be interesting. So if you look, can we go next slide? Yeah. Just to set the stage a little bit on what I'm going to talk about and why I believe it might be important, or it will be important for us, is that we see that clouds are popping up everywhere. Sometimes, and maybe this is the bad way of saying so, so there's an invasion in the network of clouds, so we get surrounded by all of these clouds somewhere. And there is various reasons or forces around that, right? And one of them is, of course, 5G, right? So if you look today, if people develop the, let's say, radio or even the core side of things, you hardly see implementations which are not cloud native, right? But before of that, actually, there was this trend in enterprises, so a lot of applications, if you look to the hyperscalers, they actually deliver a bunch of apps in a cloud native way, right? And we see even that shift happening towards the enterprises, right? So you see even so there is a number of people here in utilities and stuff like that, you see even that control systems are actually being virtualized, containerized to actually be more independent of the physical systems, right? So you see actually forces from various ways that actually drive clouds, right? So meaning they exist in the central place, so where people know AWS and GCP and Azure and stuff like that. They are deployed within, let's say, service provider networks, but you see them also appear in the enterprises and so on and so forth. And there is various reasons around that to actually make that happen is because those applications are delivered in a cloud native way. You see that there are drivers to lower latency and as such move them closer to the user. And you see also clouds appearing closer to the enterprises for privacy reasons and do very closed event loop systems and stuff like that. Now, why is that important, or why am I telling you about that? Is that Rudy talked yesterday a little bit on cloud native networking, and you see that the operational model in clouds is actually very different compared to how we are using networking and stuff like that. And a lot of us, I think if you ask who would see in the room, most of us will probably still consume our networks through CLIs. So what I call the finger-defined way of networking. So we have the finger-defined way of SDN, which is basically we are CLI disc jockeys, and that's the way we have been looking at consuming the networking, right? And going back to that as well is if you look to the shift that is happening in the cloud, there is no cloud, I would say you cannot deploy a cloud unless you have a true automation system that sits around it, because you see that in order to make systems consumable, you actually have to make it consumable by machines. And to drive that scalability and that complexity, automation is inevitable, right? So what I did and what I wanted to do in this session is the following, because I have been going through an onboarding experience. So look at the cloud, took the journey of, let's say, 5G, and looked at all the challenges that I saw in order to actually make that system consumable, right? And during this presentation, I will walk you through the journey and the lessons learned that I went through. But what I can say is that there is a number of challenges. And if you want to make things consumable and automatable, we have to do a number of things to make that happen, right? And if I compare cloud systems, one credit you have to give them, they made things very consumable. And I believe going forward, we have to see how our networks, or what are the capabilities that we have to do in the networking side to make that happen as well, and make our networks consumable, because there is no cloud without a network, right? So let's go into more details here. So, and what I will do in the next couple of slides is basically walk you through a number of lessons or key aspects that I believe are important in that journey that we have to take into account when looking at automation and cloud-native operations, right? And the first statement that I would make is that if we look at automation, we have to look at it as a product. And what do I mean with that? Is that automation is not just writing a script and doing something. If I talk about automation, we are in it for the long run, meaning if you have to give one credit to the team, and I've been part of it from the beginning, is that we deliver you things for a long time, that they are sustainable and that we can maintain it, right? The same is true for automation. We have to build it in such a way that we can maintain it, that we can upgrade it, that we can take care of changes. So we have to build it in a way that that the life cycle associated with that automation suite is supportable through a number or 10, 20, 30 years, because once you're in it forever, right? And as such, I would challenge everyone that does that with technology that are very proprietary. So the key message here is that if you look at automation, look at a system that actually is built on technologies that actually are supported by the larger ecosystem, right? Because what you will see is that you have to do validation testing, you have to do module testing, you have to check to see whether everything's okay. And if you can tap into an ecosystem to help you to support that, that would help us doing that with an effort that is much more reduced compared to if you try to have a proprietary system, right? And we'll go into more details later to see what I mean with that and make it a bit more clear. The next aspect which is important, and yesterday I think Rudy, when he was presenting, he had a big smile when he said, model-driven, we are complete, right? And when I say here, automation happens at every layer. You see in this picture, you have orchestration, a controller, and you have the network elements. And every layer matters, right? Because why am I saying that this model-driven journey has been so important for us? It is to make our systems more easily consumable, right? So what I mean with that is the following. We all talk about intent-based networking. If you look to the journey of model-driven management, you have a programmatic interface. If you say, I want to achieve this, it is going to happen, right? And that's what we achieved by going to that journey of that model-driven interface. Now, there is another important property that is sitting behind that, which is, it is programmatic, right? That means it is built for machines. It is not necessarily, so we also make a human-based interface out of it. But what is the nice property that is also there that enables us is code generation, right? Because looking at the point that I made before, we want to have an automation system that is easily maintainable and supportable, right? So if we come out with a new release of Azure OS or Azure Linux, and if the next day I can give you a plugin that makes the systems consumable, it will help us all with speed and with maintainability. And if we can make it, if we can let it generated by a machine, normally, if we do it right, there should be less issues involved, right? And as such, the speed at which we can act will be much quicker than if we have to have humans involved in that, right? So that's one thing. The second important thing is, of course, the thing, and we all talked about intent-based management. We want to say, hey, I want to achieve this. How we do that, you shouldn't care about, and it happens. And that's true at every layer. So that has to happen at the bottom layer. So if our systems are consumable in a way that you can basically say, hey, I want this VLAN, or I want this IP address, or I want these MPLS LSPs with these characteristics, and all of a sudden it happens, and you don't have to worry, okay, I was in this state before, and now I want to go here, and I have to go through all the steps to achieve that. If you can do that to say, hey, I want this, and it happens for you, it's more easy, right? And same is true for telemetry, right? So telemetry is important because we talk about intent-based networking, but the assurance side is as important as the configuration side. Because it's nice to say, hey, I can in a declarative way say, I want to set up a VPC or I want to set up a VPN, but most people want to know, is it working? Did it succeed? And what is the system that we need for that? Is a telemetry system that is consumable at every layer in order to basically tell you, hey, go to bed, everything is fine, life's good. Or if there is a problem, to find very quickly to say, okay, this interface is down, so it doesn't work yet on this side because of this and this and this problem, right? So these are all kinds of capabilities we need at every layer in order to help us do these things at scale and in a way that is easily consumable and maintainable. Now, the next thing that I'm saying is that, okay, this whole automation journey is a process, and it's people, and it's change. So what I'm not going to do in this session is say, okay, how you have to change your organization to do automation, because every organization is a little bit different. But you see a lot of people talk about DevOps, NetOps, SecOps, AIOps. There is how many of these words I've been seeing around us. In essence, if I had to summarize what we are trying to achieve, is ensure that different teams in the organization can work better together, right? Because there is the ideal world that they say, hey, I need a DevOps engineer. What is that? That's a person who can do automation, who can do programming, who understands the network and do network design, and so on and so forth. Good luck of basically transforming every person on that, and I hope people do that, because I've been personally going through that journey, and I can say it's interesting. From the moment you understand all of these principles, it's nice, but I think it's too idealistic to assume that everyone is able to do that, right? So what is the alternative to that? Is collaboration, right? So as such, if we allow people, even though there are coders, or there are people who are doing network design, and there's people who are doing security, and there's people who try to avoid the DDoS problem that Greg was talking about, if we build systems and our automation suite in a way that we can make the collaboration of these various teams easier, I believe we all benefit, right? Because it is, if to say, okay, hey, is the security of my network design okay? And if the person has to go and figure out on all the CLIs and get all the configs and stuff like that in order to get to the security person, there is a lot of effort involved, right? So what we want to do is basically build a system that allows for collaboration such that all of these, let's say, change management that are happening through the automation chain can be consumed by various people in an easy way and help what I call to ease the collaboration type of system. And that's why, just to throw in another buzzword, there is this trend of GitOps to use Git, because if you look under the hood, it is actually the best collaboration system that we have and that people in development are using. Now, I have to say, if I would ask who is familiar with Git, Git in this room, probably a lot of people will say no freaking way. So we have to make it easier for people who are not really developers to consume that, right? So that's what I mean. Collaboration is critical. So in the automation chain, we have to give you the environment to help you ease the collaboration, but not ensure that every person that is here in the room is a true developer and understands all the nitty-gritty details, right? The second important thing that I believe is important during this journey is we talked a lot and we did a lot of effort, like in FSS with the digital twin, right? You saw the metaverse, let's say, presentation where you showed this virtual reality and basically building a copycat of the network. This is another tool set that I believe is very important in order to deal with that change management that an automation system typically gives to you, right? Because if you want to do a change in the network, people can be afraid, right? Because it's the trust in the system that we have, and we want to, if you have a thing like a digital twin, it's helping us to give the trust in the change that is going to happen eventually into the network. So you can actually validate it. You can try to see that those changes are actually going to be doing the thing that you are expecting, and you actually can try to look at the changes ahead of time before to apply to the network. And the whole reason, in my view, why we would like to have these type of capabilities is to increase the trust in order to do changes, right? And these are all tools that today are very difficult and very hard to set up. So we are doing a lot of effort to ease that your life in order to actually do that change control and change management. And I think what we did in FSS is a very nice property on how going forward we have to expand from there, right? Now, the next thing is a bit maybe controversial to some people, but also important during that journey which I did going through the cloud automation side. And this is the following. Today, I think a lot of people, they are networking, so most people, data center are typically separate set of teams in an organization. Sometimes wide area network is a separate team in an organization. Optics is a separate team in an organization, and so on and so forth. And you have sometimes aggregation is separate. So what do we typically do is every person or every group wants to have its own system that does and takes care of that piece or that domain inside of a customer, right? And that is how you are organized and how you are consuming things. And what we do is we give you products to make that happen, right? Now, if you look to the cloud journey, it's very different, right? You go to an AWS portal, a VPC API, or setting up a Kubernetes cluster is a similar system, right? So that means, what I'm trying to say is that here we give you a product for a domain which has its own capabilities, whereas the cloud, if you look to the cloud guys, what they do is they give you another API to consume a service, right? Very different model and mode of operation than what we are doing today, right? And during that journey, when I was onboarding this 5G core and doing the networking stuff and so on and so forth, the challenge with the current mode of operation is that we are having to integrate all of these systems that manage various products, and we have to build layers on layers on layers to do that. If you look to the cloud world, that's not what is happening. What they basically do is they give you a set of APIs in which you can integrate directly, and they typically look all very similar. Of course, they do their specific thing for their specific domain, but at the end of the day, the framework or the surrounding are very much the same. And I sometimes make the analogy to a house, right? Or so because what we are doing today is every of us, so look at NSP, we built the best house, if you will, so the best product to look at wide area network management and automation and stuff like that. FSS is our house, if you will, to do the best data center automation and management and lifecycle and so on and so forth. If you look to the cloud, what they do is they give you, hey, here's a VPC portal, here is an API to set up a container cluster, here is a set of API to run a Lambda function and so on and so forth. It's a very different mode of operation, right? And as such, if you see that a lot of these worlds are coming together, you see that the integration of all of these things are a bit different and more easy to consume. And that's why I see a trend, and this is very, let's say, early days, but if you look at it, and if you look at automation, and if you look at it on how cloud people are consuming the systems, I say that going forward, if we would deliver our systems more as applications that are delivered on a platform, similar to how today, probably everyone here in the room has a phone or an iPhone, or not an iPhone, but a smartphone of some type, and we all install apps, right? And each of you installs your apps that you believe are the best for you, right? And so I believe if I look to the trend or how we have to evolve in this cloud-native world is similar to this type of environment. We should actually look at automation as a set of apps that are going to do a particular job, right? Now, just what do I mean with such an app, right? So an app is, for example, setting up a VPN, right? An app can be, I upgrade my network, right? Another app can be, I create a slice, right? But for example, if you need a little bit of cloud and you need a little bit of other application and so on, you want to build a system that is easily able to make those connections together. So what I'm trying to say is that going forward, we should actually look as a platform, and here we see a trend towards using Kubernetes as that platform on which we actually build application. And what are those applications? They are automation applications that give you a certain capability for your particular problem that you want to solve, right? And look at, sometimes if I make the analogy to Azure Linux, so in Azure Linux, we have a set of apps that we deliver to you, but the system is extendable to basically add a bunch of agents, we call it, right, over there, that allow you to extend the system for your particular needs and application, right? So what we are doing actually, if you look to the Azure Linux system, is actually very similar to the picture here, which is basically we deliver you a framework on which you can basically consume Nokia applications, but you can extend it for things that you believe are relevant for your particular operational things, right? And I'll give you another analogy in a bit, just to make it a bit clear. Now, what are those apps, or what are those attributes that that app should be or should have? Because, of course, if you look at Kubernetes as such, it is an intent-driven system by nature, right? So it has an API, it has a declarative way of achieving things. What you typically see where it falls short is assurance, right? But because typically what you say is, hey, I want to do X, but it doesn't tell you exactly, it gives you, did the configuration achieve, but it doesn't do is assurance, right? The second thing, what we want to have in the system is that it's completely event-driven, right? So that means that you actually can see, based on triggers, for example, the interface goes down, you see immediately, hey, my health of this service is no longer aligned with what I wanted to do, so I can take an action, right? So you want to have an event-driven system that sits behind that actually takes action immediately when something gets triggered. And then, of course, we want to go into a mode that these apps are developed by not only Nokia people, by our services organization, but actually can be developed by ourselves. So we are actually adding capabilities inside of that to make it what I call low code, no code, in order for people who are not true developers that can actually extend the system for your particular needs that you have for your particular environment. So you should see these apps as a way that easy consumable, and that people like yourself who wants to actually develop them similar to how we have in Azure Linux can extend the system for their particular needs, right? Now, yesterday, to maybe put it a bit into perspective, we talked about the ACI, so Adaptive Cloud Networking, which actually is built, some of the components are built on these principles, right? So if you look to, so the ENC as a product, right, is built around these systems. And going back to that operating system, comparing to the Android side of the things or the iOS side of things, we use Kubernetes as that operating system. And if you look under the covers, what ENC as a product does or did, is actually we extended it to automate and to consume external network devices from the Kubernetes API. And as Rudy said, why did we do that? We did that for a number of reasons. First of all, we see in those edge sites, the footprint is extremely low, right? You cannot afford to put another 3 servers there to just automate the networking side. You want to make it simple and easy. So in other words, we leverage that cloud environment and we extended it to make our networks consumable. So that's one attribute. The second attribute that we get with that is we tap into a huge ecosystem of things that are being developed around us. So if you look at GitOps, which I was talking about, you get that out of the box. If you want to control who has access to which resource, so say, okay, VLANs or this range of VLANs, this person is not able to access, we can do so, right? And so, as such, you see that if you look to Adaptive Cloud Networking, some of these components are built around those principles. Now, you could say, okay, what happens with FSS and what happens with NSP? Also here, we can make them consumable in the same way that we can directly connect to the external network devices. So we can basically build a plugin to make them consumable through the Kubernetes system, and as a result, consume and tap into that whole ecosystem that is available to us and being developed by a set of people in the industry, and tap upon the capabilities that are coming available to us, right? Now, just to make it a little bit clear, or go back to my app analogy, is that to give a bit of perspective of how you have to look at it, right? Everybody of you knows Google Maps, probably, right? What does it do to us? It basically says, I want to go from here to there, and you say, give me the shortest path, or avoid toll exchanges, and so on and so forth, set a set of constraints, and it basically helps us to go from point A to B. If you looked at what we did with Adaptive Cloud Networking and also with ENC as a product, we basically say to that app, give me a connection from point A to B with these constraints, and I'll make it happen, right? So the way you have to look at what I'm trying to explain to you is a little bit that app concept where you can do a particular thing and make sure that it happens. And if you go to that app type of analogy, you could see that we, as Nokia, we will give you a number of these applications which will help to do a number of things. But given that we build it on an open ecosystem, which is where cloud-native applications are being built, you can extend it by yourself, and we are building a framework such that you can do so, right? Of course, this is not yet available for you, but we are trying to go in that direction to actually make it consumable and make those systems available such that you can do automation for various functions and for various needs. Now, the other thing you can say is, okay, some of this stuff is rather state of the art, and I tend to agree with that. But we started to actually consume systems like that. And typically where we see this being relevant is both in, let's say, service provider, but also in enterprise sites, where you see typically the association with a cloud, right? And ELISA is one of those examples where they were onboarding a 5G cloud, but they needed SRIOV, they needed a bunch of high-speed networking capabilities. What you see today, in order to set that up, you cannot do so on a regular public cloud. So with ENC inside of that product, we basically allowed the networks, so Azure Linux and Azure OS, to be consumable from the Kubernetes, and as such, through a Google Anthos environment and Wind River type of environment, we were able to make our network systems consumable inside of that environment, and do that in a very low footprint. So yesterday, I think Rudy said, single virtual CPU. So low footprint, all the capabilities available that you want to have that. Plus, another attribute that we did, for example, like we talked about assurance, so we were able to basically stream all the telemetry that we collect from the devices and make that also then consumable. In this case, it was directly consumable by the Google Cloud system, and you can create a dashboards, do AI, ML type of analogies and stuff like that. So a bunch of things that are enabled out of the box, right? Another thing that we did, and I'm running out of time, but I think I have a few minutes from Greg, is that we also looked at slicing as a use case, right? Because the thing is, the following is, although this is at the moment a bit bleeding edge, you see that we wanted to actually explore various use cases. So the other thing that we did in Mobile World Congress is we said, okay, can we set up slicing end-to-end? So I want to have a gaming type of application. I had the people who are looking at it and doing the chatting and doing the real-time thing. And then you had the games, which was more of a very real-time connectivity, right? And we wanted to see, okay, can we set up these slices and follow those constraints and ensure that those particular things are then connected at the right place? So we had an edge cloud where you had the gaming type of application, which was a very low latency type of use case. And we had, let's say, a supportive chat and not real-time type of things happening in parallel, which were delivered on a separate slide. So the technology that I was talking about was used to achieve that. And I would welcome people on the demo booth to actually look at these demos, because actually this is something that we are actually showing during our booth. So for people interested, please come to the booth where we can actually show and go into more details on what I'm talking about here. So to conclude, and sorry to run a bit over, is that automation is a journey, right? And all what I'm talking about here is maybe interesting, and there is a lot of aspects that I touched upon, but at the end of the day, people and processes is what is important, right? So you have to look at it in your own context, how it's important, but I believe that collaboration type of idea that I was talking about is probably an interesting one to look at. And then if you look really in that cloud native operation, you see that there are it's quite a different world, right? And for me, what is important, if we really want to be successful in that journey, we have to align the framework in a way that we can make our networks consumable in such an environment. And I would happy to talk to people who wants to go into more details during the break or during the offline. And with that, I would like to thank you all, and next time is a break, I think. So thank you.